Hello, how are you? We have question 8. It says, study the opposite circuit and answer the questions. In A, they say, calculate the total resistance. We notice here that resistor R2 and R3 are in parallel. Okay, so R2 and R3 are in parallel. Okay, so to find the total of them is going to be 1 over 3 plus 1 over 12 to the power negative 1 is going to be, I use my calculator here, is going to be 2.4 ohm. Okay, so now the total of these two is connected in series with the R1. As you can see, it's on the same line. So I say R1 and the 2.4 ohm in series, right? Series, yeah, this is E, by the way, and this is E also. We know in series we simply add them, so it's going to be the R total. Okay, it's going to be R1, which is 1.6 plus the 2.4, which equals to 4 ohms. Okay, so this is the total resistance for this circuit. Okay, part B, they say, in B, they say calculate the electric current. They need the current I in the circuit. We know from before, from Ohm's law, since I have R equal V over I. Okay, so I equal V over R. What is the V? It's the total voltage provided by the battery, which is here 12 volts. Okay, it's going to be 12. And what is the R? R is actually the R total, okay, because they are asking me about the current in the circuit. It means in the total circuit. So we found R total is 4, so it's going to be 12 over 4, which is 3 ampere. Okay, this is part B of the question. We go next to part C of the question. They say calculate the voltage between points A and B. Points A and B, this is, let me go up here. Okay, between this point and this point. So basically they are asking about the voltage here in R1. Let's name it V1. Okay, we know from Ohm's law that V is actually to R multiple I. Since I'm finding the voltage in R1, this is R1, we agreed that we name it V1. So R1, I know it is 1.6 multiple the current that we just found. Maybe somebody will ask, Mr. why did you use the 3 ampere? Because notice that R1 is connected in series with the battery, so the current will go out of the positive of the battery and all of it will go into the R1. Okay, so I use the total current, which is 3. Okay, so now I use the calculator. I'm sorry for this. 1.6 multiple 3, it equals to 4.8. It equals to 4.8 volt. This is the voltage or the potential difference between A and B. Okay, the last part of this problem, I have part D. They say calculate the voltage between B and C. Let's go back to the circuit. Back to the circuit. Okay, let me first erase these things here. So they want the voltage between B, here, this point, and C. Okay, so they need the voltage in the parallel combination. Let's name it V2. I want you to pay attention, please. We agreed that here is the current going out of the battery. All the current goes into R1, and the current completes its way to go all of it inside the parallel combination. So again, I'm going to use the current, all of it, which is 3 ampere, to find the voltage V2. Okay, so we go back in here. I know that V equal R multiple I. Okay, which R, it's R, the total of the 2 and 3. I'll name it 2.3. And here, what did we name the voltage? We named it V2. So before, what did we found the resistance R23? It's from the first part. Okay, for R2 and 3 we found it 2.4, right? So I go back here, so it's going to be 2.4, this is 2.4, okay, multiple 3, it's going to be 7.2, I guess. Let me just check. 2.4 multiple 3, it's 7.2 exactly. It is 7.2 volts. Okay, this is the voltage V2. Of course, there is another way. There is another way of finding the V2. Let me do it here in this part. Okay, we know that the total voltage from the battery, let's name it V, is going to be two parts. One of it will be in R1 and the other one will be in the parallel combination here. So I can say that V equals V1 plus V2. V, I have it 12. Okay, V1 we found it to be 4.8, right? So I need V2. Simply I just take this number to the other side, is going to be 12 minus 4.8. 4.8, this is 8, okay, equals to V2. So it's going to be V2 equals, let me go a little bit up to be clearer. Use a calculator or you can do it by yourself. 7.2 volts. So this is another method of finding V2. It's up to you which one you use. Okay, now we go to the next part. I thought that D is the last part, but actually no, I have E also, E and F. They say calculate the current through R1, R2 and R3. Okay, we go up to the circuit. Let me erase the things here. Okay, so this is I. Okay, regarding the current in R1, we just agreed before that the current will go out of the battery. All of it will go through R1. So the current in R1 is actually, it's the total current, which is going to be 3 ampere, basically because R1 is connected in series with the battery. Now how about the currents in R2 and R3? I'm just going to name them I2 and I3. Okay, I can find the current in each one simply by applying Ohm's law. Let me remind you, we found V2 is equal 7.2 volts. This 7.2 volts is actually in the parallel combination, which means, as we remember from the properties of the parallel connection, the voltage in the whole combination is going to be the same voltage in here and the same voltage in here. Okay, what does that mean? It means that in the R2 I will have 7.2 volts, and down here in R3 I will have 7.2 volts. Okay, which means I can find I2, by the way this is I2, okay, I can simply find that I2 equals to V2 over R2, which is 7.2 over 3. Okay, the 7.2 divided by 3 is going to be 2.4 ampere. Okay, so I2, this one, it is 2.4 ampere. Okay, now how about the current I3? I can find I3 in two ways. Either I can apply Newton's law, not Newton's, I'm sorry, Ohm's law. I apply it here in R3. I can put V2 over R3, or simply I can say that I3 is going to be I minus I2, which is going to be 3 minus 2.4. This is minus. Let me erase and make it clearer. Sorry for this, but because I have like a small area, so 3 minus 2.4, which is going to be 0.6 ampere. So this is the I3. It's 0.6 ampere. Okay, I hope it's clear. Okay, and if you have any question regarding this problem, please leave it in the comments below. Have a nice day. Bye bye.